A great panel today on the topic is recent advances in data linkage, matching, and blending. It's a really important recent topic, especially particularly because of recent events. I think we are going to expect or hope that data linking, matching, and blending, because they're doing more and more work. We've seen the great utility, many examples of the great utility that can arise when data are linked. But some questions I have for the panel are how are recent developments going to overcome many of the challenges that we're currently facing? So one challenge is maybe that not all data can be combined. So we've seen some excellent examples about the insight that can be gained when data are combined. The combination of census and IRS data is very famous, but can most data be combined in this way? One question I pose, how are recent advances allowing us to combine ever more disparate data sets? Another problem is we like statistical inputs. We want to quantify uncertainty, and it's relatively straightforward when data are collected from a single traditional survey. But combining multiple surveys or surveys with non-survey data produces complications that cannot be handled by traditional techniques. So how is uncertainty quantified when multiple data sources are combined? And are recent advances producing new ways to quantify uncertainty in hopefully policy or in a meaningful way for application? And then finally, of growing importance is that even when data can be combined, a complicated set of rules intended to protect privacy can limit the information that can actually be reported and used. So are recent advances allowing us to mitigate the privacy risk that comes with combining an ever-increasing number of data sets? So to answer all these questions and to point the road forward and hopefully identify new and interesting areas of research is our esteemed panel. I'm going to get them up here quickly. I'm going to introduce them briefly. We have John Elting, who's Assistant Director for Research and Methodology at the U.S. Census Bureau. And he's going to talk about a conceptual framing plus operational empirical questions for the integration of multiple data sources. We're so happy to have him. We have Amy O'Hara, we're also equally happy to have, who's research professor at the Massive Data Institute and executive director of the Federal Statistical Research Data Center at the McCourt School for Public Policy. And the title is Privacy Enhancing Technologies, A Way Forward. And then also equally happy to have Martin Slasky, who's an associate professor in the Department of Statistics at the University of Virginia. And he's going to talk about linked data without the linkage. So I will invite John up. Thank you so much for panel. And I'll come back at the end and we'll field any questions you guys have in the remaining.
We can maybe do screen. Full screen.
Great, thank you.
Okay, thanks very much, John, and thanks to all the organizers as well as everybody else who did so much to ensure that this event took place today. Absolutely delighted to be here, and I was also absolutely delighted to see the questions that John posed for the speakers. I looked at all of them and said, wow, these are really good questions. I wish we'd do something about it. And then I thought, well, we knew some things about it, but there is so much more that we really should be learning. So I'm going to be responding to John's questions largely by pointing to some ways in which we can put a little more flesh on those questions, elaborate on them somewhat. And so what I'm going to be doing in terms of the slides is you'll see some underlined text. Those are direct quotes from the original abstract that Jonathan had. And then I've added some lines in italics for some suggestions for some elements that are related to conceptual framework, as well as some operational and empirical questions that may, again, help us to understand a little bit more about this. Realistically, a detailed discussion of this, we could have a full day symposium and well beyond to cover all of those. So I very much hope that this is the start of a conversation, both among the panelists and John, but also everybody in this room, because as you will see, there are enormous numbers of dimensions for which we really need a lot of additional study, and all statisticians, data scientists have an awful lot to contribute in those areas. Start with a general focused question that John began with in framing his abstract, and I'll go ahead and parse through that and again have a few further comments. started out by saying combining data sets through linkage, matching, and blending can greatly increase the utility of the data. It's a really good place to start because it helps us to, before we start launching into details, to stop and say, well, we're thinking about the utility of the information that we're providing. Well, that's utility for whom? Who are the primary stakeholders involved? And what are the primary estimands that we are considering for the time being? The answer is, John, we have millions and millions of estimands. But let's think about some primary ones that we can focus on to help put a little more flesh on these questions. Also, love what John was saying about the utility of the data. And that also is something that in various ways, both behavioral sciences in general and as well as some areas of statistics have studied to some degree, but really warrants a whole lot more study within this context. What's the value that we are delivering to a particular set of stakeholders with a given body of statistical information that we're providing? And how do we go about evaluating that utility? Sometimes the best we can do is very broad qualitative assessment. Okay, this is incredibly valuable. These other pieces of information are useful, but perhaps less so. Maybe that's all we can say. Other times we can put more quantitative structure on that. And in keeping with that, one place that I've always been intrigued about, one part of the literature I've always been intrigued about, is in the Bayesian related literature for elicitation of utility functions and priors. Can we get a little bit of a handle on both the general concepts used in those elicitation areas, as well as some software that's been developed by quite a number of authors? Could that give us a little bit more traction? Is that one way we can explore this further? And in many ways, we're dealing with a complex situation right now where we have this enormous wealth of data. And so we end up having to say, well, that's all wonderful. Now, exactly how do we go about having some structure that we put on the ways in which we take that raw data that we have and produce the most valued statistical information we possibly can? Another point to bear in mind when thinking about utility is draw a distinction that you will often see, for example, in some areas of economics, between so-called use value. We have a certain very sharply defined use that we are intending to have for this. For example, one good example is the consumer price index is used for some very specific purposes in terms of adjusting certain types of contracts. A very, in some ways, almost mechanical use of a certain body of statistical information. Other times, we really should be focusing instead on so-called option value. And somebody says, this information can be useful in a lot of different ways, but it's really premature to try to spell out every possible way in which it's going to be used. So we really need to think about the current value of prospective future use for information. And especially when we're thinking about long time series and the value that's often provided by long time series that provide an awful lot of context for understanding today's estimate. That notion of option value can be really valuable as well. Okay. And then going on to additional parts of John's initial framing question, we're thinking about providing answers to questions that cannot be addressed by analyzing each data set individually. Again, we're trying to think in this case about integrating multiple data sets. In thinking about that in detail, again, this could warrant many days of discussion, but let's start by thinking about the general notion of design. Some of you are familiar with the traditional notion of sample design, in some ways a very specified set of ways in which we draw samples and draw inferences based only on one particular, typically only one particular source of variability, sampling variability. There's a much broader notion of design, which is we have all of these wonderful potential sources of information. How do we go about allocating resources so that when we have those data and our application resources in a structured way, we can end up providing high quality statistical information in a way that is in some sense cost effective. We can define that in lots of different ways, and sustainable, again, warranting many different notions and definitions attached to them. This could involve, for example, the capture and integration of data from surveys, from administrative records, from many other sources, as well as the subsequent production of estimates based on those sources of information, and the dissemination and subsequent use of those data, including things like accompanying metadata that can have an important impact and benefit in terms of the use of that information. Okay. After that initial framing, John had a wonderful set that I'll divide into essentially three different topics. The first one is saying, well, we have ever more disparate data. We want to combine them in a certain way. If you dig into that further, it leads to an awful lot of very interesting questions related to so-called scale, scope, and complexity effects. That's something that our colleagues in engineering, especially in high-tech type of areas of engineering, have been spending a lot of time thinking about over the last 30 plus years. we really should be borrowing a lot of ideas, borrowing and adapting a lot of ideas from that literature. I had an ISI paper a couple of years ago that talked about that in a little bit of depth, given the link here. But there are many other dimensions. That's essentially just pointing some ways in which we could start to think about, again, these scale, scope, and complexity effects, and how we use those ideas to put a little bit of structure on this notion of we've got these very disparate data sets. How do we get best handle on we can? And then next part of John's question was, and are most data capable of being combined in such a meaningful way? I believe the answer is yes, but we have to parse the notion of what do we mean by most, what do we mean by capable, what do we mean by meaningful? And that's not something that we really can borrow an awful lot of ideas that we've seen develop previously. And one place to start that discussion is to say, again, what are the principal demands and what are the stakeholders' needs? And in particular, what are their inferential questions that they're trying to deal with? Are they thinking about something, again, very simple and mechanical, like using the consumer price index to adjust some type of contract value? Or are they thinking about trying to understand, in some ways, a much broader and more gestalt way of trying to understand the entire US economy or biological phenomena, other things like that? In addition, if we're trying to do this in some kind of cost-effective and sustainable way, that means we really need to think about balancing many different dimensions of quality, cost, and risk. Parsing a little bit more, John was asking how are recent advances allowing us to combine ever more disparate sources. One point to bear in mind with that is that for a very long time, the statistical world in general has had many different notions, complementary notions of quality, and all of them really get brought to the fore when we're thinking about the types of questions that we have under consideration for the session. We have one notion of quality. Accuracy essentially means square error of an estimator and corresponding characteristics, for example, coverage rates and size of confidence sets. That tends to be where we get the primary focus in traditional statistical areas, but there's always acknowledgement that there are many other dimensions that are complementary to the notion of accuracy. For example, relevance. What's the underlying concept we're trying to capture? Are these particular measures in some sense relevant to those, as well as comparability, interpretability, and so on? Many of those can be put in general in a predictive framework. We can talk about that more later, but there's also a degree to which some of these notions are fundamentally qualitative in nature, very difficult and not impossible to put much in the way of quantitative structure on, but nonetheless terribly important in terms of trying to address things. And we also have to think about multiple dimensions of cost and risk. Jonathan also mentioned questions of statistical inference, and I'll touch on just a couple of points related to that. One is that this is something that's been receiving a lot of attention over the last couple of decades. Much of that work, especially if you think about integration of multiple data sources, amount to extensions of total survey error, total uncertainty analysis work, and I've given a few literature references there. In thinking about that literature, I really love it, and at the same time, I think it's very much worthwhile to think about ways we need to continue extending that literature. And one crucial question is comparison what we might refer to as global compared to local assessment of uncertainty. If we have, as we almost always do, a very wide range of estimates of interest, for example, across different geographical areas, demographic groups, many other characteristics like that, we need to think about, in some ways, good summary indications of the quality of information that we have, uncertainty that we have attached to it. But we also need to think in a much more nuanced way about how much information we really have, how much uncertainty do we have in some ways locally, for example, for specific geographical, demographic, or other areas, and understand something more broadly about what does the entire uncertainty function look like, thinking about that entire broad function as opposed to just a single summary measure. In addition, Jonathan was asking, are recent advances providing new ways to describe uncertainty? I believe the answer is yes. And I also believe it's worthwhile to tie that in with notions that the statistical community has been wrestling with for decades. And one place I always like to go in discussion of that is go back to Tukey's classic 1962 paper on the future of data analysis. In there, he talks about two different notions of inference and related notions of uncertainty. One, he uses the label conclusions, essentially what we're accustomed to thinking about teaching in terms of formal inference. We have a very well-defined estimand. We have very well-defined understanding of what our sources of uncertainty are. We go through a lot of very careful analysis related to that, and then we can carry out some kind of formal inference with respect to those particular sources of uncertainty with reference to a particular estimate. Other times, and we've seen this especially over the last couple of decades, we think, well, that's a really great part of work, but we can also do an enormous amount of very broad exploratory work with these multiple sources of data and integration thereof. And Tukey, over 60 years ago now, had a really interesting and was clearly a very passionate advocate for that second approach, which we can usually describe as highly exploratory in nature. And he used the word, well, you're not looking for any kind of conclusion or proof. You're looking for some indication. What can you see from that information to make point us in a direction for further study, further exploration? Both of those are very much worthwhile to consider, and we need to think about different notions of uncertainty, not just in terms of a particular performance of a given estimator, but of the entire exploration process. And that's tied in very closely with notions of transparency, reproducibility, and replicability as well. Our next two speakers are going to talk, I believe, in quite a bit more depth about protection of privacy and confidentiality. So I won't say, I won't belabor that, but we have some literature references here that don't like to talk about. I do want to highlight one point related to that. When you're talking about privacy and confidentiality, we're talking about those because they're terribly important. And they are something that's terribly important for many different parts of the public that are both served by the information we're providing and the parts of the public that are providing raw information to us by way of surveys or administrative records or other sources. It's very much worthwhile for our community to try to study in further depth evolving public perceptions related to privacy. Sometimes they come and go on the levels of identification risk and attribute risk, but it's very much worthwhile to probe further on those. In many ways, one of the crucial questions that we need to think about is how do we communicate notions of relative risk to a very broad set of users, some extremely sophisticated, other ones who have a much broader qualitative notion of risk and the kind of privacy that they may be especially concerned about. Okay, we have hours of discussion we could have on this again, but I'll go ahead and stop there. Turn the floor back to Jonathan.
Not just because he mentioned my name so much. Next, I'm pleased to introduce, or I already introduced, but pleased to have Amy O'Hara here.
Thanks. All right, so when I used to work at the Census Bureau, I ran the data linkage shop, and we took the 2010 census and we matched it to administrative data. We matched about 90% of them, and people said, 90%? Why didn't you get more? And I said, well, I could have matched 100%, but there would have been 10% that were wrong. So I want to make sure that we are focusing, when we talk about data linkage, about information that has utility for the end user. You want to make sure that you're doing accurate linkages. You want to make sure that they are meaningful. And the part that I'm going to be focusing on, you want to make sure that you have respect for the data subjects that are in the list that you are matching across. And so the work that I've been doing since I left the Bureau has really been focusing on how you do better data linkage while focusing on protecting privacy. So the way I like to talk about this, you can do data linkage in the clear, which means that you might give me your list and I have my list, and it has names, and it has date of birth, and it has address, it might have social security number, it might have known associates, and that is the way that we are going to integrate our two lists. Another way to do that is by making sure, should we not trust each other, that there are methodologies that you can employ so that you can do that linkage without me having to expose my list of identifiers to John or him to me. So the projects that I'm working on right now that have a blend of this in the clear, meaning with the direct identifiers in play, as well as some of these employing privacy enhancing technologies or PETs, which I'll get a better description of in a minute. But to give you a sense of what we're working on at Georgetown, we're working on a secure query system with the IRS, where a client would be able to bring their list of people. Let's say there are people from a training program, people that are participating in a food stamps program in the state, and they would be able to have that information matched inside the IRS and have earnings aggregate statistics produced, make sure that those go through a disclosure avoidance protocol, and then return to them. So this is an example of a privacy enhancing technology because you're trying to limit who has exposure to those identifiers. Right now, we're building that system, doing that linkage in the clear, but we hope to move that forward and use these privacy enhancing technologies. The next three, the Arkansas, the District of Columbia, and the Connecticut examples, I want you guys to focus on the application of the statistics that you are working on. And these are examples where people in state agencies need to gain insights from two lists, and those lists don't live in the same organization. And many times, even within the same state, the people that are on top of those, the organizations that have the justice data and then the human services data, they don't have laws or trust with each other. So they don't want to hand over their list to even their peer in government. So we are working with them on doing private set intersections and doing privacy preserving record linkage demonstrations so that they can have the insights drawn from their data when you link them without having to expose their list of identifiers even to a peer within government. And in DC, we're working on this currently with synthetic data, but they will be moving later in the year into using real student data. They want to understand whether people who go through high school in the district end up working in Maryland and Virginia. You're like, why don't they know that already? Because there's laws and there's data protection and they don't trust each other. So how can you come up with ways to employ these statistical methods that help them get these insights that they really need? The final bullet on there, the National Center for Education Statistics, that is on the ropes right now, but NCES is a statistical agency in the Department of Education, and they currently do linkages in the clear. They're using Social Security numbers to match a survey response file to the federal student aid data by SSN. And we were like, whoa, why are you still doing that? Isn't there another way that we could do this? And so we did a demonstration working with a fellow that was embedded inside the department while the department's still there, and to do this demonstration project so that you would not need to do that linkage on those exposed Social Security numbers. I just wanted to ground my comments in the need for these technologies to be put in application on the ground to protect your data, your cousin's data, your neighbor's data. This is why moving this forward is important. So privacy enhancing technologies, PETs. These are cryptographic techniques that you employ because you want to be able to do the statistics, produce the statistics that you're aiming for, but you want to do that without using these direct identifiers in the clear. And they can really help us as we're figuring out how you do better data sharing, how you do better data analysis. And they are just ways to kind of up our game from where we currently are to where we could go. And the two that I mentioned on that previous slide, privacy preserving record linkage, which is where you have your list of identifiers, and then you agree on a hashing method so that then you're doing that linkage on the hash values. There are even further applications of this in fully homomorphic encryption. We're actually doing that linkage on the hash data. Another example is secure multi-party, and this is where you're taking the data and you're splintering it. So some people, some machines might actually have a little piece of the data, but they don't have enough to make any real inferences from. And the piece that they have is also encrypted. So this is a way of taking sensitive data, making sure that it is indecipherable, and then being able to produce these linkages that we want. So this sounds like, oh, is that space age? No, this is something that's actually going on. This is work that has been developed largely in the Intel and the DoD community. They use it. Why aren't we using it more in the executive branch agencies? Well, that's because it's hard and there are lots of barriers. Just to run through these, there are legal barriers, there are institutional barriers, there are technical barriers, and there are cultural barriers, okay? And these are all things that we need to be chipping away at so that we are able to have better deployment of these methods across the board, especially bringing it back to that previous slide. People in the states actually want this. They actually are testing it, and they are trying to figure out how they change the way that they do business to adopt these PETs. But it's going to take trust in the methods. It's going to take buy-in from their leadership which is hard in political cycles. It's going to take inertia that you need to break from what they've been doing and figure out how they could adopt this. And there may be actual legal barriers, but a lot of the time from our studies, we find people that say, well, we can't do that. Well, where is it in your code or your statute? And it's just that they haven't done it before. So it's really overcoming the newness of these techniques and getting people to test them and adopt them. An example, and this is kind of like a big picture example. I was fortunate last year we came out with the report. This is a National Academy's report about linking income, consumption, and wealth data for the United States. And these are the big files. You need data from census, you need data from SSA, you need data from IRS. And we are talking about population level linkages where you're going to end up with billions of records. And this is just a schematic, and I would urge you to read the report because it really gets into a lot of these issues. What are the legal hangups? What are the technical hangups? What are the definitional hangups? This needs buy-in from economists and statisticians and a lot of political folks. But you would start with the entire population of the US from the census or from the IRS, and you would be linking additional data sources to be able to gain these insights. Because right now, we've got pretty good income data. We have it from surveys, we have it from administrative data. We have really lousy wealth data. Okay. And it would be great if we understood that together. And we have even worse consumption data. Yes, we have the CPI. Yes, we have the consumer expenditure survey, but that is the sample survey. How would you be able to infer this information for the whole population? And that is where you have this beautiful join of the economists and the vision they have for the way that you would be able to construct these measures. But it's really going to take a lot of buy-in and a lot of difficult linkages, because some of these data sets have SSNs, some of them don't. Some of them have addresses that are out of date. It's going to be a big challenge to figure out how you do this. And I was delighted to work on that with colleagues from a lot of the Georgias and Maryland to come up with the privacy protecting chapter in that book. Further, last slide. I want to tell you that there are a lot of people in this country and around the world working on this. And on the left side of the slide there, I would like to invite you to go look into the International Population Data Linkage Network, IPDLN. And these are people, it really started with the Canadians and the Brits, and then the Australians got involved, and the Americans were kind of late to the party. And now we have been pushing it into other countries around the world. These are people that do these full population linkages. And some of them love to talk about their methods, and they love to talk about the efficiency and the amount of time it takes to run. And then some of them are talking about the applications. And I just threw a short set of examples of what was presented at the meeting that we had in September to give you a taste of the sorts of papers that you would find in the link to that issue that has all of the abstracts. The next international conference is going to be in Rotterdam in 2026, but that's a ways away. So in June of this year, we are hosting at Georgetown a domestic version of this conference. And I would invite you to look into that. We have special rates for students. We are going to waive the fee for feds, but we are having a conference June 24th and 25th at the McCourt School. So this is not Georgetown over by Foggy Bottom. This is Georgetown by Georgetown Law. They just built a big new building for the public policy school. That's where we're having this. And I would also point out that the day before that, there is going to be a half-day linkage workshop that is going to cover the basics and the cutting edge. And we are so lucky. We have Abel Coe from Northwestern. We have Sean Granis from Regan Street. And so we have absolute rock stars that are going to be doing this workshop. And it should be a fantastic time to kind of learn a little bit about how you get started, and then also having them point you to the resources and the open source tools that you would be able to employ to do data linkages yourself. Finally, my email is there. Please feel free to reach out. I'm happy to talk about any of these topics or to connect you to others if you have specific questions. But thank you.
And then last, we have Martin. We're happy to welcome back to George Mason and excited to have here. I'm going to assume. Yeah, that's in line. Yeah.
Well, thank you very much to the organizers, and thank you very much, Jonathan, for putting this very nice panel together. Thank you also to the previous panelists. Very nice presentations, which I think also have been greatly making some of my points. And yeah, it's terrific to be back. Yeah, so I will talk a little bit about, thoughts that came out of, like research I've done on record linkage, particularly, like how do you analyze linked data sets? And then I will, I think, try to, point out some of the limitations that come with, linkage or linked data. And then, trying to, maybe think about what could be done that, enables analysis even without doing linkage. Okay. All right. Yeah, so I think record linkage has been like quite a big success story. And the main reason, I think perhaps the main reason is what John mentioned in his talk, cost effectiveness, right? Because we don't want to collect new data sets all the time, right? We know that data collection is expensive and, also causes a lot of problems by itself, such as non-response, right? So why not just using the data set that we already have, right? But from a data analysis perspective, perhaps the problem is somewhat, I don't know, somewhat easy. I mean, it's more like a missing data problem, right? So you have a data set, essentially like a bunch of variables. And then, there's maybe a few that you're missing. And, you could do this without linkage, right? You could try to impute them or like, I mean, there are many different ways, but, in some sense, right? So the data analysis problem is somewhat simple, right? And so here we're talking about micro level data, right? So you have the year persons and, you have a second database and then you have some sort of, matching variables and then you use those to connect linkage. And yeah, so there's been a lot of progress concerning, software for doing these things. Most of them based on the flaky Santa model. Like there's this really nice Python implementation that just came out probably like a year or two ago, which is based off FastLink, some of like, SQL like tricks and hacks. And these are now, widely available, everyone can use them, relatively user-friendly. And there's also a lot of advances in like machine learning essentially to do the linkage, right? So it's not just for center. If you have some sort of training data, you can use like your favorite ML model to classify links but not links. And there's like huge number of applications, like say electronic health records. Now a lot of people are digging through historical records and trying to link those, criminal justice data, social media data, like you name it, right? So so this sounds all like really good and exciting. So I want to talk about some of the common criticisms. And the first point is kind of, the uncertainty or, how do you identify links if you don't have good identifiers or fuzzy identifiers? And perhaps my criticism is something that John also kind of touched on, is namely transparency and reproducibility. And it feels to me like even though the package is out, seems that everybody using their own set of hacks to essentially, at the end of the day, come up with like set of links and non-links. And these things are often like heuristic and you don't find them codified. There's not like essentially like an established guideline, that, everybody could use, that people could read. And, every data set you want to link comes with their own set of anomalies, right? So there's not just one universal, set of rules that people apply. And people don't even give all the details, right? Because often the details are messy and nobody wants to, write a document that's just like a list of hacks or heuristics, right? So people don't really want to do these things. And then the second point, now, as you know, you have uncertainty or links, right? Some of them might be wrong. And then, you cannot just ignore incorrect links. So if you do that, you can have like very significant bias and, analysis that you do downstream, right? So that's something what I call post-linkage analysis. And as of now, this problem of post-linkage analysis like generally unsolved, right? So I mean, it is successful under a specific set of conditions, ignorability assumptions, and so forth, right? But this is still a very active field of research that I've been working on for a while. past several years. Yeah, so then the second one is, this is also related to that, and also to things that were said before is, representativeness. Like, when we link, does the link data set represent the target population of interest, right? And so Amy mentioned, we don't want to have any incorrect links, right? We don't want to have 10% wrong links, but then the other side of that is that you could actually miss some subpopulation altogether, right? And so here, this example that I'm showing is from the linkage between health and retirement study and the Census Business Register. And so a lot of this was based on addresses, and some of the addresses were just, not very informative. And, then, you had records, many records that couldn't be linked. And you will see that among the unlinked records, you have like a larger proportions of minorities, or people, that they're immigrants and, maybe of low income, right? So that's something that I think also should be taken into consideration in this kind of analysis of linked data aspect. Then the third one, this has been discussed before, and see, I'm trying to make like a different point, because Amy talked about sharing private identifiers like name, addresses, social security, and so on. So that's just one aspect, but there's another problem, namely, when you link data, you essentially pile up information, right? And essentially, when you look at, say, these three variables here, rank of the professor, college, and year of hire, if you look at these three cells, they're just a lot smaller number of individuals in each cell than if you just have rank and college. Okay, and as a result, your disclosure risk goes up, right? For example, there's not going to be too many people that are going to buy this associate professor in a given college in a given year, right? And then having all three together, probably relatively easy to guess like people's salary. And so that's in such a different aspect, right? So other than just thinking about, identifiers, and that will get much, much worse as you're linking more and more files. So the idea is just not having too many pieces of information together at a single place. So record linkage is not really reconcilable. That is actually does the complete opposite. And then the last one, this is perhaps, people would say, of course, but record linkage requires that the statistical units that define the two files, that they're actually the same or overlapping. And this is actually quite limiting, because often you don't have this. For example, you could have two surveys that are taken from the same population, but the individuals in the two surveys are not the same, so you cannot link them, right? And so just essentially making this restriction that we work in the same populations, will limit us as to the kind of analysis that we can do. So what else you could do if you cannot do record linkage, or you don't want to do record linkage? So there's something called statistical matching, and statistical matching, say you have two variables, X and Y, and you want them to bring them together in a single file, right? But you can't, because don't observe them together. You have X in one file, you have Y in another file. But then what you often have is you have a third variable, or a third set of variables Z. So now you try to match on the set of variables Z, right? Again, so then, not same individuals, but you can do that, and then you can bring together like all these three variables in a single file. And then, you can do analysis essentially involving X and Y. So I have one problem with this is that, you cannot have all possible sets of, dependencies in the linked file. And the reason why is that is because any dependence that you have between X and Y in the linked file has to be induced by the matching variable Z. Okay, and that requires then that X is conditionally independent of Y given Z. And so you cannot verify this assumption, right? Because you don't have microdata paired records for X and Y. So this is not a testable assumption. So now I want to propose something new. So this is something we call unlinked data analysis. And I think, this has some advantages. And it can perhaps address some of the issues that I mentioned before. And one of the things is, for example, we cannot link all data sets we want to link, right? Because there's a lack of trust between different institutions that hold them. It may also help with this privacy issue that I mentioned. And it does not require an assumption as in statistical matching that I was mentioning before. So the assumption in this framework, which is fairly recent, but it has some connection to things that were done in causal inference. So the key assumption is transportability. And so essentially what you assume is that at the level of random variables, which generate the data, you assume that, say, y is the transformation of the other random variable x may be subject to some noise, okay? And, there's been a bit of study lately and, trying to understand when this map f can be learned. And, there's a lot of ongoing research right now. And there's been some progress, and I think a lot of very interesting problems related to more like, fundamental math, that kind of things. So the first question, for example, when can we identify f star at all, right? When can we identify this transport map? And so it turns out you can do this if this function f star is monotone, with no direction of monotonicity. You can also do it essentially for optimal transport maps, which is the generalization for higher dimensions. You can also essentially estimate this function in practice, and the things which are used in that, they mostly relate to mixture models, optimal transport. And the third one, and this is something fairly recent, which I'm working on right now, is they just studied the linear regression case. And you can actually show that under some conditions you can get the same estimation rates as in the case where you have paired data, meaning like square root d over n type of convergence. In general, of course, this is still not identifiable, and we're trying to find conditions that are fairly general to allow that. So here's like just for example, that kind of showcases the idea. You have like household income from 2 years, and this would be analysis based on the linked data. And here on the right, this would be what we're essentially proposing. You have essentially 2 data sets, you never link them, but you kind of try to learn the transformation that connects these 2 data sets, and then you can get an estimate that's not terribly different from what you would get if you actually have linked data sets. So we think this is like a really exciting direction of research that could transcend the boundary of what is currently done. And yeah, so that's, I think, all I wanted to say. And happy to take any questions later.